And back to the tutorial for deep learning. Today I want to continue the image classification session, that is part 2 video, that is how we can achieve image classification using VGG for predict whether the given image, that means given input images are belongs to cat or dog, where participate in the Kaggle competition 2 here. So as I told you in the image classification thing, the VGG is one of the familiar CNN model we are going to utilize here, and we are going to combine everything with the help of transfer learning, because transfer learning is one of the very familiar technique where which is very useful and allow to pre-train the data. Suppose if your data set, you can pre-train the data for enhancement, further enhancement and fine tuning also. With the help of transfer learning with VGG network, we can fine tune the network and improve the accuracy of the results too here. So quick recap. So first of all, we initializing the packages, then we are preparing the data set. As I told you, GitHub only we are following the data, where you have image classification CNN with VGG combination, where we have more than 21,000 image, around 21,000 images there. After importing, after bringing the data, we are going for the things like image height, set, batch size, and we are going to print the first last 5 lines of the data set. Then we are going to load and pre-process the image. So if you have any image, there will be a noise is there, you can remove the noise and make it a pre-process. After pre-process, you can go to the particular size pre-process, and then you can go further thing. And we are going to check the shape of the XIN data and data set and check the images. So if you want to check the images, we can call the function called definition space plot images of image SLS, like that. And when I go like this, we can randomly print the images of cat and dogs, okay, my combination of both. Now we are going to build the CNN network, the fundamental one. So if you want to design the fundamental CNN, as of you know, CNN consists of a convolution layer, pooling layer, max pooling layer, fully connected layer, and so on and so on. So these are main things there. Everyone reduced for reduce the space dimensionality, and a flatten layer, dense layer, and we can extend anything. And here we are going to use the Adam optimizer, because the one of the familiar popular optimizer that adapts the learning rate during the training. That's the advantage, and also it's one of the good choice for making deep learning talks also. And here we are representing the binary function, binary cross interview only. This is one of the last function which measure the difference between the predicted probabilities and actual labels too here. And we are using the construct the model with the help of summary, where it will help to construct all the layers and print the total parameters and training. So if you want train and test the approaches, you can write the code, and with the help of this content drive project dog versus cats my model definitely takes some time. After successfully running the approaches, you can go for further thing, that is model history. You can define the plot model history followed by the axis model accuracy, epoch value, train, validity, loss, speech, and so on and so on. So once you train the data set, and how do you know whether our data set is working properly or not? It's based on the model accuracy as well as the model loss. Here model accuracy should be more and model loss should be less when you go for that one. Then we can say our data set successfully predicted the value images and utilized for the predict the differentiation between the cat and dog here. Then you can avoid the overfitting to here, and we can use the dropout method and batch normalization. Here we have doubt about batch normalization. There are a lot of things about the batch normalization. I will say some points to understand purpose. Here is one of the layer that help to improve the training of our deep neural network only, and also by normalizing the activation of the previous layer too. And why we need this batch normalization means it will help to stabilize the learning process easily, and improve the convergence speed, and act as a regularizer, and allows higher learning rates to here. So lot of benefits there when go for batch normalization. Later we discuss if you want. And evaluation. So if you want the evaluation, we can use import cbone as a SNS, and we can try to print the values like test accuracy, loss accuracy, since I told you. Then we can write the coding, and we need support of confusion matrix. So what is this confusion matrix? It's one of the familiar one. It's one of the performance measurement tool generally available for all kind of classification problems. And here it's also come under the category of supervised learning. Here we have to remember, and it also helps to visualize how well your or our classification model is performed, especially by showing the types of errors in making here. So with the help of performance matrix or confusion matrix, we can predict the data set and everything, how the matrix support and like that. Here once you execute it, you may get the accuracy of 0.93 and loss of 0.28. This is very good only. So if you want, again you can add transfer learning or move on to the next stage of VGG network here, and then we can go for generate the classification report. This report developed and printed with the help of the another matrix called precision, recall, F1 score and support here. These are the common metrics available in the image processing tools and etc. And data augmentation. So since I have about data augmentation, because after pre-processing done, we can go apply the image data generator from the Keras. Here image generation is one of the class in Keras and also helpful to generate the batches of image with real-time data augmentation here. Moreover, it also always helpful to increase the diversity of your training data also and reduce overfitting here. And we can apply the rescale here, where it rescale the pixel value of the images from the original range of 0,255 to range of 0,1 like that. And here we can apply random horizontal flipping also. And remember, so what is use of this image data generators and augmentation? With help of this, suppose you have a training data of 100, we can increase up to the 1000 and so on. So we can make replica many of the things with the help of this kind of data generator with data augmentation. Then rotation. So if you want to apply the rotation, we can apply the operation like rotation. So the images will be rotated, where we take the range from the some images. So training, if you have a data set, what you can do, you can spend the training 80% of the training and 20% for the testing itself. Then zoom augmentation is one of the specialization technique where helpful to zoom the images. So if you have doubt about the or if you want more clarity, we can go after training with one, we can implement this one. It will send the 21,000 images by default, and then we can pull together everything, that means join together, where again we can set the rescale with the shift and validation data and some images we can print here, and we can retrain and again train the data network, data set for improve the accuracy. And we can train, where we are adding the layers like dropout, batch normalization, dropout and batch flatten, dense layer, and again implementing the Adam optimization, where it's useful for the binary cross entropy. And we can go for the new model with the help of that is transfer learning with VGG-16, and again test approaches. If you want to again repeat the test and then go for check the model accuracy and model loss. So accuracy should be more and loss should be less. And at last we are combined the transfer learning with VGG-16, where fine tuning the data set everything, and we can write the code for layer and loss layer. Then we can combine here with the help of binary cross entropy. After this, it may print the results, construction of this model, summary and so on. Then train the model, again check the approaches up to value of something, say 351 and so on. Then save the model and again check the model accuracy with the model loss here. So if you once go for this one, we can give the better results. Observe it, before we got 0.93 only, but we are getting the 0.95, and last values before it was so high, that is 0.28. Now we are getting the last value 0.12 only. So whenever you want to make successful image classification with the help of the transfer learning, we can move for this kind of things only, data augmentation, and train the VGG with the transfer learning and reduces. And once again we can go for the confusion matrix here. So simple and coding. So confusion matrix is one of the measurement tool, just I told you. And what from you can understand here means, here the function from the sklearn matrices will helpful to calculate the confusion matrix, which always compare the true label of y underscore g here. See here y underscore g with the VGG underscore y underscore p. That means you already have some actual data, that data set with images, and after that you can predict the images. Now both will be combined here, and it will calculate all the things like true label, confusion matrix, at last show the images, like show the information like this 590 like that. And once again it will print the, at last end of the session, it will print the precision value, recall value, f1 score value, and